rational numbers. The key word is ratio. And a rational number divided by another number, A over B, will result in a rational number. But do keep in mind, not always, sometimes it will just result in a natural number, or even a whole number. So we want to know the difference between natural numbers, whole numbers, and numbers. I believe this comes on later in the chapter, but I'll write it over here. The set of numbers 1, 2, 3, 4, ... They're called natural numbers. If you include 0, it is called whole numbers. We will leave it there for the time being, and we can visit this later on. So when we divide a number A by another number B, we have a ratio and we get a rational number. And the nice thing is we to lower terms. We can keep on reducing until we get the lowest term possible, beyond which you cannot reduce. Oh, didn't mean to do that. Second cannot equal 0. Going back to the previous video, the denominator becomes 0. We have an undefined number. So B cannot equal 0. And we have something called an equivalent fraction. So you can take a number, rational number, A over B, multiply and divide by any number you want. I'll call C over C. The answer is still A over B. This is something you might have seen before in school. C over C is just 1. So you're multiplying A over B by 1. So the answer is still A over B. So as an example, if I have 7 over 11 and I multiply and divide by 2, the answer is, because we want to write the rational number in the lowest terms possible. Reducing a rational number. So when I have A over B, A is the numerator, B is the denominator. What we want to do is find prime factorizations of the numerator and denominator denominator and cancel out common terms. Beyond a certain point, you would not be able to get rid of any numbers, at which point the rational number to the possible. Reduce (125) divided by 100. Keep in mind, fundamental theorem of arithmetic, we could always write any number as a product of prime numbers. So start with the prime and 5, that would become 25. 25 times 5 is 125. 5 times 5 is 25. Nothing more can be done. And 105, that would give me 20. 20 times 5. 5 times 4 is 20. 2 times 2 is 4. Again, this can be done using the calculator. Is to say as to why things work the way they do. So numerator will now become 5 times 5 times 5. The denominator would become 5 times 5 times 2 times 2. The 5s would get cancelled. Divided by 4. You've got to notice something. Well, before we get to that, you can't reduce this further. This is the best I could do. Because factorization, and for me to get rid of more terms, it's just not going to be possible. So numerator number is bigger than the denominator. What we have is an improper fraction. Because the numerator is on the denominator. Well, you reduce an improper fraction, the answer will still be an improper fraction. Naturally, when you reduce it, the numerator is bigger than the denominator. I have 5 over 4. I get an improper fraction. So proper fraction, numerator is less than denominator. And we have something called a mixed fraction. Mixed fraction that has a special notation, but only if can be expressed as mixed fractions. So what is this mixed fraction business? 5 over 5 plus 1 over 4. So is 1, oh, sorry, that's bad math. I'm sorry. It's 1 plus 1 over 4. So 5 over 4 is 1.25. And if I split that 1.25, I'd have 1 plus 0.25, 1.25. I will get 1 plus 1 over 4. But I can write 1 plus 1 over 4 as 1 times, or not times, 1 over 4. This notation that you see here is what we call a mixed fraction notation. You have an improper fraction. Now, this is an easy problem where I was able to recognize that 5 over 4 is 1.25. I split it up, wrote it as 1 plus 0.25. And wrote it this way, called it a mixed. But if you have a complicated number, how would we go about doing this? All you have to do is divide 5 by 4. 4 times 1 is 4. You get 1. That's the remainder. So when we write a mixed fraction, all we do is we write the remainder divisor. So 4 is 1 is the quotient. One is the remainder. Values and writing it as remainder, quotient, divisor. And if you want to go back to the fraction, is add, multiply remainder and divisor. Those two. So you multiply, you would add. And you put it over the divisor. So in my problem, I have 1 over mix. I showed you how I say dividing 5 over 4, but if you have a complicated number, you have to do long division and so forth. Again, we have calculators these days, and this might seem trivial, but we just have to understand the process, and that's the key. So to go back to 5 over 4, first, I have to multiply 4 and 1. the resulting answer to the quotient, divide by 4. Is plus 1 over 4. We end up getting 5 full. So 96 over 72. Next fraction. Clearly, 96 proper because the numerator is bigger than the denominator. Naturally, the improper fraction can be written as a mixed fraction. So all we have to do is come up with the prime factorization of 96, prime factorization of 72, cancel out the common terms. So 96 could start with 3, because 3 is prime, the lowest prime, and that would give 32. Now, 8 times 4 is 32, 16 times 2 is 32, but the only prime number here would be 2. So 2 times 16, 32. Again, the prime is 2, 2 times 8, 16. 2 times 4, 8. 2 times 2, 4. So the prime factorization of 96 is 3 times 2 times 2 times 2 times 2 times 2. For 72, 72 is simply 24 times 3. 3 is a prime number. Of course, you could start with 2. Nothing wrong with that. I just wanted to start with 3. So 24, 3 times 8. 8, 2 times 4. 4, 2 times 2. And that is it. So 72, I can write it as 3 times 3 times 2 times 2 times 2, which would mean 96 over 72 would be 3 times 2 times 2 times 2 times 2 times 2, divided by 3, 3, 2, 2, 2. Get rid of common terms. That is the best we could do. So I have 4 over 3 because numerator is 2 times 2, denominator is 3. I know what the mixed fraction is going to be, but I'll show you how we can do this. So 4 is divided by 3. 3 times 1, 3. Remainder is 1. We can't go any further. So take that 1, put it up here. Take that 1, put it up there, and divide by 3. So it's 1, 1/3. So 1, 1/3 is nothing. So we want to reduce 108 over 72 and express it as a mixed fraction. Prime factorization they start with the number 2, because it's a prime. 54 times 2 is 108. 2 times 27, 54. 2, oops, bad math. 3 times 9, 27. 3 times 3, 9. 2 times 36, 72. 2 times 18, 36. 2 times 9, 18. 3 times 3, 9. So the numerator is 2 times 3 times 3 times 2 times 2 times 2 times 3 times 3. We'll get rid of the common terms. We have 3 over 2. 3 over 2 is an improper fraction. I want to write. So 3 over 2 is half. Get rid of the plus sign. I can write it as 1 1/2. Or you could take the division approach that we did. So far we've just seen improper fractions and writing it as a mixed fraction. What would happen if we have the process of reducing will be the same, but proper fractions result in decimals because the numerator is always I should say always. I shouldn't say always because there are arguments that we can make. They would result in decimals. 2, 3, etc. Now, 1 over 2 is 0.5. 1 over 3 is 0.33333. So since the digits are repeating, we can write it as 0.3 and put on 3 repeats. 1 over 5 is 0.2, easy. And let's take 1 over 9. If we did 1 over 9, I will get 0.111111. We'll keep on going. Again, I will write it as 0.1 and put a bar above it, indicating that 0.1's repeating itself. But there are cases where 2 digits will repeat. So So 0.232323, if it keeps So put 0.23 and put a bar above it. So this is what I meant by proper fractions result in decimals. More precisely speaking, proper fractions would either result in a terminating decimal, which is 0.5 ending, repeating digits, or the case where it doesn't repeat at all, in which case it would become an irrational number. So what is the property of rational numbers? Rational numbers will result in a whole number. It could be positive or negative. Now they are called integers. I don't want to get into that now. I'll save it for a section later on. Or a terminating decimal of a proper fraction. Example 0.5. A repeating decimal. Example 0.7 repeating. 0.16 repeating. Lastly, it can result in a mixed or improper fraction, which again, you know, it can be expressed as a decimal. So rational numbers will satisfy these conditions, both or terminating decimal, or a repeating decimal, or end up in a mixed fraction, but by all means, mixed fraction and proper fraction result in decimals. So we want to express 0.1. There is a bar above it, which means the digits are repeating, and we want to express it as a fraction and reduce it if necessary. Sometimes you do the process and you end up with a fully reduced fraction. So how do we go about doing this? So we start with 0.1 bar. I'll call that n. That would mean 0.11111 keeps on going. Since it is a single repeating, I am going to multiply both sides by 10. So one repeating digit. So which would mean 10n multiplied by 0.111 keeps on going. If you multiply a decimal by 10, the decimal moves to the right by one place, would end up having 1.11111. It will keep on. So 10n is 1.11111, keeps on going. And I know from earlier that n is 0.11111. going to subtract on both sides. So 9n would equal to 1 minus 1, 1 minus 1, 1 minus 1. So I will end up having 0, 0, 0, 0, 0. If it's happening for those, the answer has to be 0 repeating also. So 1 minus 0 is 1. So I can write it as 1 repeating zeros. But if 0 is the only thing that is repeating, I can get rid of that 0 and simply write it as 1. Unless there is another digit that is not a 0, right move. We don't have to specify the decimal point. So 9n would equal to n, 1, and divide by 9 on both sides. End up getting, this it tells us if you take 1 and divide by 9, we will end up getting 0.11111. It's exactly what I had earlier when I was talking about rational numbers. 1 over 9 is 0.11111. But now we were able to go from a repeating decimal to a fraction by using the simple process. So we want to write 0.7 repeating sevens, repeating decimal as a fraction. So I'm going to set n to be 0.7 repeating decimal, which would simply mean 0.7777 keeps on going. Since it is only one digit that is repeating, I'm going to multiply both sides by 10. n would equal, since I'm multiplying 0.7 by 10, we move the decimal to the right by one digit. So 7.777. I'm going to subtract n from 10n. So n is 0.777. When I subtract, I'll simply get 0, 0, 0 repeating. 7 minus 0 is 7. 10n minus n is 9n. I don't have to specify 0, 0, 0, 0 after the decimal. So is 7 over 9. Okay. So I wanted 1/6 repeating as a fraction and reduce it if at all possible. So I'm going to set n to be 0.16 repeating. That would mean 16, 16, 16. Last time we had one digit repeating, so we multiplied both sides by 10. Here we have 2, we're going to multiply by 100 on both sides. So we multiply by 100 on both sides. So 100n would be equal to 100 multiplied by 0.161616, which would be 66, because when you multiply 100 by a decimal, we can move the decimal digit or the decimal by. So 100n is 0.1616 repeating. I am going to subtract n from it. So n is 0.1616 repeating. Subtract 6 minus 6, 0, 1 minus 1, 0, 6 minus 6, 0, 1 minus 1, 0, 16. 100 n minus n. So 99n, which would imply n is 16 over 99. So the given value is 0.27 with a bar on top, which would imply it is 0.272727 repeating. So n is 0.272727, keeps on going. Since two digits are repeating, I can multiply, or I should multiply both sides by 100. So 100n would be equal to 27.2727 repeating. Now I'm going to subtract the n, which is 0.2727 from 100n. 7 would go away, 2 minus 2, 0, 7 minus 7, 0, 2 minus 2, 0, 27 minus 0, 27. 100n minus n, 99n. So n is equal to 27, which would mean n is 27 divided by 99. You may say, well, I'll just stop there, but that 27 prime factorization, 3 followed by 9. 3 times 3 is 9. 99, I'm going to go with the biggest prime number because it's going to make things easier. 11 times 9 is 99, and 3 times 3. So the new 3 times 3. 11 times 3 times 3. Cancelling out the common terms, I simply end up having 3 over 11. So we want to combine 5 1/3 and 1/3. If we want to combine fractions, the very first thing that you should do is make sure that both fractions are either proper fractions, improper proper, or improper improper. In other words, if you have a mixed fraction, you have to convert it to an improper fraction. We know how to do that. We first multiply 5 and 13. 5 and 3, which is 15, and add it to plus 1, 16. Add, this is what I mean by combine. So 16 over 3 plus 1 over 3. Key here is having a common denominator. If you have a common denominator, I can put it as one denominator, 3, and combine the numerators. You can only do this if you have a common denominator, which I do in this problem. So first step would be to convert those mixed fractions to a regular fraction, proper or improper, doesn't matter. In this case, it would be improper. So we know how to do that. 7 in the denominator by 1 and 7 added to 5. 1, 5, 12. So 1, 5 over 7 is simply 12 over 7. Three times 2 over 7, more 3 and 7 in the denominator, which is 21. Added to 2, I'll get 23. Which would simply mean I'm adding 12 over 7 and 23 over 7. A common denominator of 7, add the numerators, 12 plus 23, which is 35. So keep in mind, 7 divides 35, so the answer is 5. Here I want to add 3 over 8 and 1 over 3. Unlike last problem, or the last two, the denominator and the denominators are not the same. So one is 8, the other is 3. So we want to come up with a common denominator. The common denominator would simply be the least common multiple. What is the least common multiple between 8 and 3? It is 24. So going back to earlier, we went over the concept of equivalent fraction. So 3 over 8 and 3 over 8 times 3 over 3 are one and the same. I'm multiplying and dividing by 3 because I'll have the common denominator, 24. Why 24? 24 is the least common multiple. Multiply and divide by 8. I'll get 24 in the denominator. 3 times 3, 9 over 24. 1 times 8, 8 over 24. I now have a common denominator. So 24, add the numerators, 9 plus 8, 17 over 24. So I have 3 over 4. Want to write it as an improper fraction. 4 in the denominator. 3 times 4 is 12. 12 plus 3, 15. 9, 1 over 7. 7 in the denominator. 9 times 7, 63. 63 plus 64. We've got to add those two. I do not have a common denominator, but the least common multiple between 4 and 7 is 8. So how do I get a 28 in the first fraction's denominator? I multiply and divide by 7. How do I get a 28 in the second fraction's denominator? Multiply and divide by 4, because 4 times 7 is 28. Fifteen times 7 is 105. 64 times 4, 156. Now I have a common denominator, which is 28. Numerator is simply 105 plus 256. In those, you'd get 361 over 28. There is no need for us to simplify, because we can't simplify this further. Write the improper fraction rather than a mixed fraction.